Okay, this is Algebra 2, Objective 27, absolute value inequalities. Previously we talked about absolute value equations, which might look something like this. So 3x minus 1 equals, let's say, 2. So we had an absolute value equation. Remember that we needed to split it into two separate equations, where we said 3x minus 1 equals negative 2, and 3x minus 1 equals regular 2. And then we would simply solve each one of these and get two answers. So you have two answers. Today what you're going to see is absolute value inequalities, and there's two different inequalities and we treat each one different. So you need to know if we're doing an absolute value less than problem or an absolute value greater than. So if you see one of these signs which points left, that means we're doing a less than, and here we're doing a greater than. Alright, solve a greater than inequality. The reason we're going to do this greater than first is it's a lot like our equals one. Solve an absolute value greater than. This one's simple. There's no junk in the box. It's just x. Absolute value of x is greater than 5. We're going to flip this into two inequalities. Kind of like previously where we took this and broke it into two different equations. It's kind of the same concept. All right, for one of the inequalities, flip the inequality and make the right side a negative. So basically this is absolute value of greater than. So we're going to say x now ends up being less than negative 5. And then the other one is x is greater than regular 5. So we kind of have the same thing that we had before where we had, all right, absolute value of 5. So this one goes absolute value is, it's always less than the negative 5. And over here it's just greater than the regular 5. So that's how we break it up when it's a real simple one like this. Absolute value greater than problems end up being x is less than negative 5, x is greater than regular 5. Let's look at another greater than example. This one's more complicated because before you can even break that down into two, you have to isolate the absolute value box. So think of this as like a big old variable, the big box. First thing we do is add the 1 over. And we get 3, absolute value 2x plus 1, is greater than or equal to 21. Then we have to divide the 3 off. Don't minus the 3 off, don't add the 3, don't multiply the 3. This is like 3 times a box, so just divide both sides by 3. And we get the absolute value, 2x plus 1 equals, what's 21 divided by 3? 7. Now that the box is isolated, now we can break it into two separate inequalities. The first one we're going to end up saying the 2x plus 1, the stuff in the box, is less than or equal to negative 7. And then we're going to say the stuff in the box is greater than or equal to regular 7. So we got our 2x plus 1 is less than or equal to negative 7, or 2x plus 1 is greater than or equal to regular 7. Notice that this one right here is basically the exact same as this. We've just gotten rid of the absolute value. But there is going to be two answers. So it's 2x plus 1 less than or equal to negative 7, 2x plus 1 greater than or equal to regular 7. And if you ended up ever having to graph these, this would end up being an OR problem. You'd put them both on the same number line and then just take everything that gets shaded. All right, the one on the left, minus 1, 2x, less than or equal to negative 8. And x is less than or equal to negative 4. Minus 1, 2x is greater than or equal to 6. Divided by 2. X is greater than or equal to 3. So that's how we do a greater than problem. All right, now less than. On absolute value less than problems, these are where you end up getting the three-headed monster. So it's not actually a hard thing to do, but this is what the process is going to be. We've got absolute value of x is less than or equal to 3. So you're going to make a three-headed monster with two less than signs. First thing to do is you put -3 and +3 on the outside. And then whatever is in the box comes to the middle. So in this case, it's just x, so you put it in the middle and you're done. If there was more junk inside the box, you'd have to put all of it right inside here. And this is what we're going to call a three-headed dragon or a three-headed monster. We've got a left side, a middle side, and a right side. So it's a three-piece compound inequality, a three-headed monster, so to speak. All right, so let's try this next one up top. Before we can do anything, we have to isolate. There's nothing over here being added or subtracted, so all you got to do is divide by 6, and you'll have the box isolated. So now you got absolute value of this junk is less than 4. Anytime you have absolute value less than, you make a three-headed monster. Take this 4. Draw these two arrows. Over on the left side, it's -4, and on the right side, it's regular 4. The stuff in the box, which is more than just x this time, it's some junk, it's some algebra-looking junk, all that gets to come in the middle. Now this time you're not done here, you actually have to solve it. So you have to -2 on both, well, -2 on all three sides, really. -2, -2, -2. -6 is less than 3x is less than 2. And then you have to divide all three sides by 3. And then you're done. Fortunately, it's just 3, so there's no sign flipping. So being -2 is less than x is less than 2/3. Here's the next one. Isolate the box. This time you need to add 1 first, divide by 2. Add 1. Divide the coefficient off the box. And the absolute value of -6x plus 5 is less than or equal to 3. Absolute value less than means we're going to have a three-headed monster. Also keep in mind that is a negative coefficient on your x. That will come into be a problem here in a minute. All right, take this 3. It's an absolute value less than, so it's a three-headed monster. -3 on this side, regular 3 on that side. -3, 3. All this stuff in the middle goes to the middle. Or all the stuff in the box goes to the middle. Now you've got a three-headed monster, a three-piece compound inequality. Solve it. -5 on all three sides. Now it's -8 is less than or equal to -6x is less than or equal to -2. Notice the coefficient on the x in the middle is negative. As you divide all three sides by -6, you have to flip both of these inequalities. -6, -6, -6. That crosses there. This makes positive. This is 4/3. If you don't see that, put it in your calculator, but if you just reduce 8/6, it becomes 4/3, and it's positive because we got negative over negative. 4/3, sign flipped, x. Sign flipped, 2/6 becomes positive 1/3. All right, and now you have a three-headed monster, but it's flipped backwards, so you have to take this answer and you have to flip it so that the smallest number is on the left, and you use less than signs. So this is a good answer, but you will not see that on your multiple choice answers. It's always going to look like this: 1/3 less than or equal to x less than or equal to 4/3. If you don't understand what I mean by flip it, look at what I have, look at what I flip to get the right answer, have it written down, wrap your mind around it. If you don't see it, just keep staring at it until hopefully maybe you figure out what I just did right there. And I got 4 problems over here. These are special. Notice this is an absolute value less than. Let's just take note of these. These are like the trick problems. So take note of them. Absolute value is less than -4. Remember, the absolute value means the distance between some number and 0. If I said the distance between some number and 0 is somehow coming out to be a -4, that wouldn't make sense because distance is always positive. So there's no way that this and whatever number you put in here, no matter what it is, I could put -10 in here, and I'd go, that's -30 plus 2, so -28. But then in absolute value terms, it becomes regular 28, and it's not less than -4. There's no numbers you could put in here to make the left side end up being less than -4, because anything less than -4 is negative. So it's automatically no solution on this. Anytime you have absolute value being less than a negative, it's just not going to happen, because absolute value is a distance. The distance is positive. Same as the next one. This one's an equation. Instead of saying less than, it just says the absolute value of 3x plus 4 equals -7. For the same reason, this is a distance. Whatever this junk is, it's somehow a distance between 0 and whatever we get. And the distance will never come out to be a -7. There are no -7s on the rulers. No -7s on the yardsticks. There's no -7 miles. So this one is an automatic no solution. Absolute value equals negative, no solution. Absolute value is less than negative, no solution. Now, this one's different. An absolute value, a distance can be 0. If I'm standing here and I don't move, I'm going 0 distance. I'm not going to go negative distance. If I move, I go positive distance. If I'm standing here and I go backwards, I still moved a foot. I didn't move a negative foot. So you can have a absolute value equal negative. All you got to do is find the number that would make this box be 0. To do that, say 3x minus 2 equals 0. That'll help you find the number that'll allow this junk to be 0. 3x equals 2, x equals 2/3. So if you took the number 2/3 and you said 3 times 2/3, subtract 2, it would come out to be 0, and the absolute value of 0 is 0. So absolute value equals 0. Work it out like it's a regular equation and find that there's one solution. This one is a different type of trick question. I've actually never seen it on the accelerated math multiple choice questions, but just to think about it, absolute value greater than -2. This is going to be all real numbers. But why? Think about this. Absolute value is some distance. I want to know what numbers will make this distance be greater than -2. Well, I'm going to tell you, any number that you put in is going to, the lowest this could be is that you could put in the magic number that makes this 0. But any other number that you can think of and put in will make this a positive number. So any number that you can think of is going to work and make this be bigger than -2. So it's all real numbers because, same reason, absolute value is always, and when it's all said and done, an absolute value is always going to come out to be something positive. So no matter what number you think of, if you put it in this box, it's going to work itself out, and it's going to end up being positive. 3 things to remember. First, when we started, we looked at an absolute value equation. Remember, you break your absolute value equations into 2. What's in the box equals -2. What's in the box equals regular 2. Then we looked at absolute value greater thans. Treat greater thans and less thans differently. Absolute value greater than breaks into 2. You say x is less than the negative of whatever's here, and x is greater than the positive, whatever's here. And then lastly, when you have absolute value less thans, you make a three-headed monster, less than sign, or in this case, less than equal to, less than or equal to. Put negative 3 on the one side and 3 on the right side. Whatever's in the box comes to the middle. If there's junk in the box, you put it in the middle, you keep working. If it's just x, put it in the middle, and you're done. All right, that's objective 27, absolute value inequalities. Always keep in mind, if you see anything tricky, to go to the page that says take notice of these. Those are the trick questions. Keep them in mind. All right, hope that helps. Have a great day, and I will see you guys next time.